Okay, so let's go ahead and do some two-step stoichiometry problems. Okay, so let's go ahead and go straight into practice problems for two-step stoichiometries. For these problems, we're going to be going from either from mass A to mole B on our mole island map, or we're going to go from mole A to mass B on your mole island map. And if you notice those two different options, you're going to be taking two rafts or two arrows to get there. That is why this is called a two-step stoichiometry problem. But before we go straight into two-step, if you notice between mole A to mole B, it says mole ratio step. So let's do two examples about mole ratio and what that is. So problem number 1 says how many moles of LiOH are required to react with 20 moles of CO2, and you're also given a balanced chemical reaction. For all stoichiometry problems from here on out, you're always going to be given a balanced chemical reaction with it. So like what we did when we did our mass mole conversions, we're going to circle what we are given and underline what we're trying to solve for. So in this problem, we are given 20 moles of CO2. Now this problem also asks us to solve for moles of LiOH, so let's underline it. The difference between this one and mass mole conversions right now is when you underline what you're trying to solve for, you're not only going to underline the unit, but also the compound, because as you notice, for this problem, we're going to go from CO2 to LiOH. We're converting between two different compounds as well. So since we circled moles, that means we're going to start at mole island. And since we underline moles, we're also going to end at mole island. Now, the first letter of the alphabet is A. Therefore, we're always going to start at the A side no matter what type of stoichiometry problem we have. So we're going to start at mole A. Now, like I said before, we are going from CO2 to LiOH. These two are two different compounds. That's why we're going to end at the B side. So mole B. That's the difference between A to B. We would go A to B if we're changing compounds. Now, from here on out, all of our stoichiometry problems from today all the way to the end of this chapter and for the rest of the trimester, so on your homeworks, on your test, you're always going to go A to B always. So now that we know what island we're starting at, what island we're going to, let's go ahead and rewrite what we circled. And we circled 20 moles of CO2. And after that, we would always follow that with the times in a line like we did for mass mole conversions. Now, we're going from mole A to mole B. On your mole island map, it says mole ratio step when you go from mole A to mole B. That is a conversion between compounds. Now, in this problem, we underlined LiOH. Since we underlined LiOH, that goes on the top. We will put LiOH on the top of our line. You also know this because you see how LiOH is already on the top of our line in the problem. You just put it on the top of the line on your work. Now, we circled CO2. Anything circled, any compound circle, is going to go on the bottom. Now, these also have to be with numbers. And if you remember from balancing chemical reactions, mole ratios is the coefficients in the reaction. So looking at our chemical reaction that's given, LiOH has a coefficient of 2, so it's going to have a 2 with it. Now, CO2 does not have a number, and we know in chemistry we never write ones in chemistry, so that means the coefficient for CO2 is 1. So that is our mole ratio step. Every single time we complete a step, we always want to cancel what we have 2 of. In this problem, we have 2 CO2s, so let's cancel it. And now we are ready to go ahead and solve that. So the way we would do just the same as we did for mass mole conversions, you would multiply the top and you would divide the bottom. So what you would do in your calculators, you would take 20 times 2 divided by 1, and you would get 40. Now don't forget, we still got to do sig figs. The number of sig figs we start with should be the number we end in. 20. We only have one significant figure. The reason why that 0 is not significant because it's not sandwiched, and yes, it's after a non-zero, but there's no decimal point in the number. So we start with one sig fig. And with that idea, Our answer 40 also has 1 sig fig, so that means we don't need to do rounding for this one. So our answer is 40. We solved for moles because that's what we underlined. And we underline LiOH because that's what we're solving for. So it's going to be 40 moles of LiOH. And that is your final answer for problem number 1. So with that idea, let's go ahead and do another mole ratio step problem. Problem number 2 says how many moles of NH3 are produced from 6 moles of O2? And again, we're given another balanced chemical reaction. So let's circle what we are given and underline what we're trying to solve for. We are given 6 moles of O2 and we're solving for moles of NH3. Now since we circled moles, that means we're going to start at mole island. And we underline moles, so we're going to end at mole island. Now, again, A is the first letter of the alphabet, so we're going to start at mole A. And in this problem, we're going from H2 to NH3. Those are 2 different compounds, so we're going to end at the B side. So now that we know what island we're starting at, what island we're going to, let's go ahead and rewrite what we circled. 6 moles of H2. And if you look at your mole island map, we're going from mole A to mole B. That step's called mole ratio, conversion between compounds. Compound underline goes on the top, compound circle goes in the bottom. The compound we underline in this one is NH3, and the compound circled is H2. Now we get these numbers by looking at the coefficients in the reaction. NH3 has a coefficient of 2. And H2 has a coefficient of 3. Now since we're done writing out this step, we got to cancel. We got 2 H2s, so they go away. And now we're good to calculate. So we're going to multiply the top, divide the bottom. So in your calculator, you would do 6 times 2 divided by 3. And that gives us 4. But again, we cannot forget about significant figures. We have start with 1 sig fig. So we have the end in 1 sig fig. But our answer 4 is 1. So we don't need to do rounding for this one. So our answer is 4. We solved for moles because we got to do our unit. And our compound that we solved for is NH3 because that's what we underlined. And that is your final answer for problem number 2. Okay, so let's go ahead and start doing 2-step stoichiometry problems since we know how to do mole ratio step when we're going from mass A to mass B. So this problem says how many moles of C6H12O6 are produced from 3.00 moles of H2O. Same thing that we do before. Circle what we were given, underline what we're trying to solve for. In this problem, we're given 3.00 moles of H2O. And we're finding grams of C6H12O6. Since I circled moles, we're going to start at mole island. Now here, I underlined grams. We know grams is mass, so we're going to end at mass island. Now, since the first letter of the alphabet's A, we're going to start at mole A. And in this problem, we're going from H2O to C6H12O6. Those are 2 different compounds, so we're going to go to mass B. So now that we know what island we're starting at, what island we're going to, let's rewrite what we circled. Moles of H2O. So now, in this problem, when you look at your mole island map, we're going from mole A to mass B. That's 2 wraps. This is going to be a 2-stepper, meaning there's going to be 2 times in a line. Since we're starting at mole A, our first step is mole ratio. Remember, conversion between compounds. Compound underlines on the top, compound circles on the bottom. So on the top, we got C6H12O6. And on the bottom, we got H2O. We get the numbers from the balanced chemical reaction. C6H12O6 has no numbers, so it's going to be 1. H2O has 6. And in this step, we cancel out our waters. Make sure you are canceling every single time because you will mess up your stoichiometry work. Since this is a 2-stepper, we got to do another one. We just did our mole ratio step, so now we're at mole B. And to get up to mass B, one more step is going to be molar mass on top, 1 mole on the bottom. So we have to solve for the molar mass of the compound we have in our work. That is why it's very important you cancel, because the only compound that's not canceled in our work is C6H12O6. Now, if you did not cancel H2O out like you're supposed to, you would have done the molar mass of H2O, but we no longer have that. That's gone. So let's find the molar mass of C6H12O6. Carbon has an atomic mass of 12.01. We got 6 of them in the compound. Hydrogen has an atomic mass of 1.01. We have 12 of them in the compound. And oxygen has an atomic mass of 16, and we have 6 of them in the compound. So if you plug that in all into your calculator, you're going to get 180.18 grams/moles. And that is what we're going to plug into the top, where our mole island map tells us that our molar mass is going to be in. And looking at this step, we have 2 moles, so that's going to cancel. And now we're good to calculate it. And the way you're going to calculate this one is very similar as before. We're going to multiply the top, divide the bottom, then we're going to multiply the top again, divide the bottom. So the way you would plug this one in is you do 3.00 times 1 divided by 6 times 180.18 divided by 1 and equal that out, and you should get 90.09. Now we still got to do our significant figures. 3.00, we actually have 3 sig figs. The reason why these 2 zeros are significant because they're after a non-zero and there's a decimal point in the number. So we start with 3 sig figs. So we got to end in 3 sig figs. First 3 significant numbers in our answer is 900. The 9 tells me the 0 goes up. So our final answer, I'm going to put it below here, is 90.1. We solved for grams of C6H12O6. And that is your final answer. Okay, so now let's go ahead and do one more 2-step stoichiometry problem. This time we have how many moles of AgO are needed to produce 125 grams of O2. Again, circle what we're given, underline what we're trying to solve for. We are given 125 grams of O2, and we are solving for moles of AgO. So, since we circled grams, we're going to start at mass island since grams is mass, and we underline moles, we're going to end at mole island. Now, since A is the first letter of the alphabet, we're starting at mass A. In this problem, we're going from O2 to HGO. Those are 2 different compounds, so we're ending on the B side. So we're going to mole B. This time, we're going from mass A to mole B. So now let's rewrite what we circled, what we're given. 125 grams of O2. Now, we're going from mass A to mole B. If you look on your mole island map, that is 2 steps. It's 2 different lines, 2 different rafts. So the first line we got to go to is 1 mole on the top and molar mass on the bottom. So we have to solve for the molar mass of the compound we have in our problem. And we have O2 in our problem. So let's solve the molar mass of O2. Oxygen's atomic mass is 16, and we have 2 of them, and we know 16 times 2 is 32. And 32 goes on the bottom, since molar mass goes on the bottom. And in this step, we have 2 grams, so let's cancel out grams. So now we just did our first step, so from mass A, now we're at mole A, and get to mole B, the last step is mole ratio, conversion between compounds. Compound underline goes on the top, compound circle goes on the bottom. So the compound we underline is AgO, compound circled is O2. And we get these numbers that go with them on our balanced chemical reaction. AgO has a coefficient of 2, O2 has no coefficient, so that's going to be 1. And in this step, our O2 cancels. So now we're good to go ahead and solve it. So we're going to multiply the top, divide the bottom, multiply the top again, divide the bottom again. So on your calculator, you would do 125 times 1 divided by 32 times 2 divided by 1. And you would get 7.8125. But again, we got to do our significant figures again. We start with 3 sig figs. All 3 of these numbers are significant. So we got to round our answer to 3 sig figs. Our first 3 numbers is 781. The 2 tells me the 7 stays the same, so our final answer is 7.81. We solved for moles of AgO. And that is your final answer, and that is how you do two-step stoichiometry.